Hey everyone, moving on now. Chapter 3. Last week we reviewed Chapter 1 and Chapter 2. This week we're going to review 3, 4, and 5. So this is Chapter 3. There's a lot in this chapter, so hopefully most of this will come back to you. If not all of it, don't worry, we will be coming back to it in future chapters. All right, this chapter is mostly about inequalities, and I just wanted to highlight some important points. So if we're going to graph the inequality n is less than 1, that means we're graphing everything to the left of 1. So less than 1. And if it's just less than, we use an open dot. Okay, so the open circle means less than. The next one, we're looking for a letter A that's greater than or equal to 0. When we're equal to, we close in this dot because it includes that 0. See, closed dot shows that 0 is a solution, so it includes 0. F greater than -3, just greater than, open dot. Now what we want to do with this is anytime we see something look a little different, we just want to rewrite it. And remember, the mouth should open to what it opens to. We don't want to keep the sign the same just yet. So we would read this, x is less than or greater than, or less than or equal to -2. All right, it's always easier to write it with a variable on the left side. So, and then remember, we read it as this one up here, A is greater than or equal to. So when the mouth opens left, remember we want to think of that as an alligator mouth, and it wants to eat the largest amount of stuff. So that would be A is greater than, it's bigger than 0. All right, when the mouth opens the other way, as in the first example, it's less than. All right, solving inequalities. So solving inequalities are very, very similar to solving regular equations with one exception. And that's if you multiply or divide both sides by a negative number, you need to flip the inequality. So down here, I don't know if I have an example down here. Hopefully we do. It looks like we do. So number 18, we have 7 minus 6b is less than or equal to 19. So we want to isolate the b. So we do order of operations backwards. We subtract 7 from both sides. We get -6b is less than or equal to 12. And then we divide by -6. And when we divide by a negative, we flip the sign with inequalities. So that turns into b is greater than or equal to -2. And then that is your answer. We isolated b, we flipped the sign because we divided by a negative number, and we moved on. Now remember, just as when we're solving equations, sometimes we need to simplify the equation first. So I'm going to rewrite this as 15f plus 9 is greater than, and I'm going to distribute this because it's going to make it easier, 15f plus 3. Well, we have a 15f on both sides, so if we subtract 15f, they should both cancel. And we're left with the statement 9 is greater than 3. Well, when is that true? It's always true. So whenever it's always true, we're going to just write all real numbers. This is always true. So for whatever value we plug in for f, it will be true. So all real numbers is what we put. 9 is greater than 3. That is always, always true. And then remember, if we get something where it doesn't make sense, so if it was 3 is greater than 9, that's when we would use the no solution answer. All right, we also have something called compound inequalities, all right, where we have something in the middle. All right, when we're solving for one of these, we just have to do it to each side, or we want to think of this as two equations, which might be the best way to do it. So we have -3 is less than or equal to m minus 4, and then m minus 4 is less than -1. So we want to solve these separately. This one we want to add 4 to both sides. We see that m is greater than or equal to 1. And then this side we add 4 to both sides. We get m is less than 3. So we can put it back together. M is greater than or equal to 1 and less than 3. So that's a compound inequality. Here's another notation we can use. This is called interval notation. All right. So instead of writing x is greater than or equal to 2, we're going to just say, if you draw it on the number line, it's greater than or equal to, so it's closed in. Anytime we have a closed in dot, you want to use a bracket. All right. So a bracket, and then this line goes from 2 to infinity and beyond, right, Buzz Lightyear? All right, so 2 to infinity is what this means. And then since infinity doesn't close, we're going to leave it as a open parentheses. Open parentheses means it doesn't include that number. And so for the next one, x is less than 2, open circle on the number line. If we're going from left to right, we're starting at negative infinity, because it goes on forever from the left. And then it goes up to 2, but doesn't include 2, so we're going to use parentheses. X is between 1 and 5, but it's less than or equal to 5. So we have an open dot at 1, we have a closed dot at 5, and we want everything in between. So open dot, we're going to use parentheses, 1 to 5. 5 is a closed dot, we're going to use a bracket. Lastly, we have an OR statement here. All right, remember, OR is going to look like this. So we have x is less than -3, open dot, x is greater than or equal to 4, closed dot. Anytime we have an OR statement, we're going to have two different intervals like this. Absolute value of inequalities. Okay. So with the absolute value, it's similar to compound that we have to solve two inequalities. But here what we do is, if we look at this first example, if it's greater than, okay, we're going to use or, greater, or, greater, or. All right, so 8n greater than -24, or sorry, 8n is greater than or equal to 24. We're going to write that expression out, and then we're going to also flip the sign and flip the expression, or flip the sign and change the sign, so that we have 8n is less than or equal to -24. And that's because if you could plug in -8 or 8 in for n if n represented either or, and you'd get the same answer because of the absolute value sign. So we have to check the inequality both ways. All right, and greater than will make it or. So 8, we would just solve this equation. We would divide both sides by 8. N is less than or equal to negative 3, or n is greater than or equal to 3. When we have a less than or equal to sign after the absolute value, we're going to get a compound inequality. So with that, we would want to set it up as the original statement, which is w minus 213 is less than or equal to 5. And then we want to flip the sign and then change the sign for the second one. Our other equation here would be w minus 213 is greater than or equal to negative 5. Flip the sign, change the sign, and then we would solve for that. All right, just a quick review on sets. All right, sets are written in brackets. All right, so if it asks for the set which defines the inequality, we would say x such that x, which is what this little line means, is less than 2. Okay, or simply if it's in the braces here, then 2, 3, 4, 6, 8 could be a set. The union vocab word there of two sets includes every element of each set to form a new set. So if I were going to say I have a set 2, 3, and I have a set, I'm going to call this set A, I'm going to call this set B. So my first set is 2 or 3, my second set is 4 or 5. A union is written with a U, so the union of sets A and B would equal each element in those sets. So we would have 2, 3, 4, 5. The intersection of two sets form a new set. So here we're going to say, we're going to call this something different, so not to confuse you, we're going to call this C. Set C we're going to say is 2, 3, 4. And then set D is going to be 4, 6, 8. Then the intersection, which is the opposite of union, so it's going to be an upside down U. The intersection of sets C and D is the common elements of those. So the only thing in common in those sets is the number 4. So the intersection is only using common elements. The union is using all elements. Okay, and then the complement of a set. So if we're going to use set C from above, the complement of C would be written like that, and that means everything that's not in C and sometimes that's known as C prime. So if C is 2, 3, 4, and we're talking all real numbers, then the complement would be all real numbers except for 2, 3, and 4. And that's it. You'll have a couple questions to answer after this slide, and you'll have your check for your understanding. You will also have class time to ask questions. Hope to see you guys there. Have a great day.